So we have been talking about physical and chemical properties of matter. So physical properties can be observed or measured without altering the identity of the material. So we can classify it in two things: intensive and extensive properties. So the ones that are intensive are the properties that they do not depend on the amount of matter present. And we can use these properties to identify our materials. For example, density, melting and boiling points, color, odor, ductility, malleability, luster, hardness, and solubility. So all these properties about a chemical, they're not going to change. It doesn't matter if we have 1 gram of that chemical, 5 grams of that chemical, 1 kilogram of the chemical. It doesn't matter. We're going to have the same intensive properties. On the other hand, extensive physical properties, they do depend on the amount of matter present. So they are things like mass, volume, length, and size. They all depend on how much of your chemical you have there. So let's talk about chemical properties. They are the ones that describe the ability of a substance to undergo a change that is going to alter its identity. So we're going to be looking at flammability, reactivity, and toxicity, for example, to see if that substance has chemical properties to change its identity. For example, here, the corroded pipe is not going to be the same pipe anymore. It has been corroded. So it changed the way it looks. It changes identity. Same with the combustion of gasoline. It's not going to be the same liquid now. It has undergone a combustion reaction. We can see gas coming out. So these are chemical properties of matter. What I want you to do is to click pause, fill in this table based it on if blue color is a physical property or a chemical property. If it is a physical property, then state if it's an intensive or extensive physical property. Okay, so as we can see here, blue is a physical intensive property, density is the same thing, solubility, and melting point. They are physical, describing and we can use them to identify our materials, and they're all intensive. Doesn't matter how much we have of them. For example, the density of an apple, it doesn't matter if we cut an apple in half, both halves are going to have the same density. On the other hand, flammability is a chemical property. The reaction with acid to form hydrogen gas is a chemical property. Supports combustion, chemical property. Sour taste has undergone a chemical reaction, so chemical property. Same thing here. Can we pause now? We can see that how our substance reacts with water to form gas is a chemical property. How it reacts to base to form water is a chemical property. But the hardness and the boiling point, they are physical properties and they're intensive. It doesn't matter how much of the substance we have, they can have the same physical properties. Can neutralize a base, so this is a chemical property of that particular substance. Luster, odor, malleability, and ductility, they're all physical properties and they are intensive. It doesn't matter how much of the substance you have. Now let's talk about the physical and the chemical changes. A physical change, its matter will change its physical state, but not its composition. So frequently, physical changes are reversible. For example, when we do phase change, when we talk about water, we have ice water. It undergoes a phase change to liquid water, but still water, still H2O. And then water vapor is still H2O, it's just a different phase change. So they are physical changes. Sharpening a pencil is still the same pencil, we can write with it. Salt dissolving in water. We can actually reverse this change. If we evaporate the water is just going to go and phase change to vapor, and the salt is going to remain there. Weathering of rocks. If we see this big rock, we can have cracks or smaller size. They're all still the same thing. They're still rocks. So this is undergoing a physical change. So we talk about the phase changes. They're all physical. And just as a review, going from solid to liquid, it's called melting. But going to liquid to solid, freezing. Liquid to gas. When it's really, really hot, we call it vaporization. When going from gas to liquid, condensation. Now these two might be new words for you. Going from something gaseous to something solid, we're skipping the liquid phase. This is called deposition. And going from something solid straight into gas, like dry ice, this is called sublimation. And we have a video here about iodine. Going to gas to a solid, skipping the liquid phase. Gas to solid deposition, that was the last part of the video. So what are the difference between solid liquids and gases, if they're all physical changes? Well, if you look at these pictures that are here on the bottom, look at the molecules and how tightly compact they are. Solids, liquids, they have a little bit more freedom. In gases, they're really far apart. So solids, they're tightly packed, have definite shape and volume. You can easily calculate this. Usually high density, but not all of them. Expand slightly when heated, and almost incompressible. You cannot compress them anymore. The liquids, on the other hand, have a definite volume according to their container. Less dense than solids, most of them, not all of them. We're going to see that water is one of the exceptions to the rule. Flows, has fluidity, particles slide past each other, expands more than solids when heated, not all of them, and almost incompressible. So these are just the general rules. Gases, particles do not touch each other. They can make collisions, but they typically do not touch each other. No definite shape or volume. Low density. Take the shape of its container. Expands greatly when heated. As you can see here, it's just going to start expanding and more pressure here. And highly compressible. We can compress it more. So the more we compress it, it's going to become a liquid, and then it's going to become a solid. So increasing this pressure can also change the phase. This is something that we did in lab. There's something similar. We took some ice in the solid form. We started melting them and started to record the temperature. So then we noticed that it went to the liquid phase, and then after some time it went to the gaseous phase. Endothermic happens when the substance absorbs energy. So here we have the solid, the ice. It's going to absorb energy. So the more energy it absorbs, the molecules are going to start moving faster. So they're going to start spreading apart. And then as we absorb more energy, they are going to go into the gaseous phase. They're going to be spreading apart. But going this way, going from gas to liquid to solid, we're going to be releasing this energy. So we're going to go this way. Endothermic, absorbing energy. Exothermic, releasing that energy. Now this is something called the phase diagram. And we can see our three phases here: solid, liquid, and gas. We know that going from something solid to something liquid, we call it melting. And going from liquid to solid, we call it freezing. Going from gas to liquid, condensation. From something liquid to something gas, vaporization. In our two new words, going from gas to solid, deposition, and going from solid to gas, sublimation. Now at this point right here, we can have solid, liquid, or gas at the same time. So our substance is going to go into equilibrium, going from solid to liquid and gas. All of the three at the same time. This is what we call the triple point. All phases are present, they coexist. And then one more point that I want to mention is this one, the critical point. So at this point, even if we start applying more pressure, we can no longer apply pressure to liquefy it. So it doesn't matter how much we apply, we cannot. Doesn't matter how much we do to liquefy a gas. It's just going to be at this point. Those were the physical changes, phase changes, physical changes. Now, about chemical changes. They involve new substance being formed. So we have the roasting of marshmallows, digestion. What you eat is going to get breaking down, and then you're going to have those enzymes and acids in your body, so it's going to look really different. And the roasted bike. Same thing, new substances being formed. So these are the indicators that we're going to see when there is a chemical change. Unexpected color change. Change in temperature is going to include a chemical change. Just like the like fire, it's going to exothermic. Gas is produced, just like the lab that we did with vinegar with sodium bicarbonate. And then when we see something else being formed, in this case something solid, a precipitate, this also indicates a new substance, a chemical change. Again, click pause to answer the following based on if it's a physical change or a chemical change.